Hello students, welcome to the Automotive Mechanical Motor Vehicle Transmission System. Today's topic is synchromesh gearbox. Upon the completion of this session, you will be able to explain the need for synchromesh action in a gearbox, list out the different types of synchromesh gearboxes, explain each type of synchromesh gearbox, explain the function of a synchromesh unit, explain power flow in different gear positions, explain the advantage of synchromesh gearbox over sliding and constant mesh gearbox. Now that we have listed out the learning objectives, let's get started without any delay.
Gearbox. Gearbox manual transmission. A gearbox is used to get different torques and speeds which are required to overcome the following resistances: road resistance, air resistance, gradient resistance, load on vehicle. By engaging different gears, engine torque is increased while speed is decreased. In the top gear, the RPM and torque of the engine and gearbox remain the same. Simple gear train. When there is only one gear on each shaft, it is known as simple gear train. When the distance between turn shaft is small, it is used. When a small gear 1, figure 1, drives the bigger gear 2, the RPM of the bigger gear 2 is reduced in proportion of the gear tooth. For example, gear 1 is having 10 teeth and gear 2 is having 20 teeth. Assuming gear 1 rotates at 50 RPM, here the RPM of gear 2 is half of gear 1, so torque will be double. It means in higher gear, the torque is less and in lower gear, the torque is more. Different sets of gears are used in the gearbox to achieve different speeds and torques. Compound gear train. When there are more than one gear on a shaft, it is called as compound gear train. When the distance between the driver and driven has to be bridged over by intermediate gears and at the same time, high gear ratio or small gear ratio is required, then the advantage of intermediate gears is intensified by providing compound gears on intermediate shaft. Powertrain figure 2. The drive shaft 1 along with gear 2 is always rotating at the engine RPM. The shaft 1 drives the countershaft gear 3, 4, 5 and 6 which are fixed on the countershaft. The gears 7 and 8 on the main shaft 9 get power from the countershaft's respective gear when engaged. To get the desired RPM or the torque, the respective gear on the main shaft 7 or 8 is engaged with the countershaft gears 7 and 8 which are splined on the main shaft. When these gears are engaged with the countershaft gears, power is transmitted to the main shaft 9. To get the reverse speed, the idler gear 6 is used in between the main shaft and the countershaft gears. Gear selection. The selection of gear depends upon the speed if the vehicle is to be driven. For example, the speed and appropriate gear selection of a vehicle is given below. Gear selection, speed in kilometers per hour. First gear 15, second gear 30, third gear 45, fourth gear 65, fifth gear on top gear 80. Types of gearboxes: sliding mesh gearbox, constant mesh gearbox and synchromesh gearbox. Sliding mesh gearbox. In this gearbox, the gears are mounted directly on the main shaft 1. The gear is slided on the main shaft with the help of the shifter yoke mechanism 7 to engage with the countershaft 2 gear. The gears on the clutch shaft 3 and countershaft 2 are fixed. The idler gear is always in mesh with the countershaft's gear. To achieve reverse speed, the main shaft's one gear is slided on the main shaft to engage with the idler gear 4. To slide the gear on the shaft, the shifter forks 7 directly sit on the main shaft's one gear. The shifter forks are connected to the gear shift lever through the selector rods 8. In this type of gearbox, spur gears are always used because the gear is slided on the shaft to engage with the counter shaft gear. Constant mesh gearbox figure 5. In this gearbox, the gears of the main shaft 1 are always in mesh with the corresponding gears of the counter shaft 2, but power is not transmitted unless the dog clutch 3 or 4 engages with a particular gear on the main shaft 1.
The main shaft is splined. In between the splined main shaft and gears, bushes 5 are provided. The fixed dog clutch 6 is splined on the main shaft gear 1.
Therefore, the gear and the fixed dog clutch both rotate freely without transmitting power. The dog clutch can slide along and revolve with the main shaft. When the sliding dog clutch 3 or 4 is engaged with the respective gear's fixed dog clutch, power is transmitted from the gear to the main shaft through the sliding dog clutch 4 and fixed dog clutch 6. In this type of gearbox, helical gears are used. Advantages: the power transmission is smooth when helical gears are engaged because more than one tooth is in contact at a time. Easy to engage. Less wear of gears in comparison to the sliding mesh gearbox. Because gears are always in mesh and gear shifting is done through the sliding dog clutch. Gearbox troubles. Gear noise. The following are the causes for noise in the gearbox: wrong adjustment of gear shifting fork, misalignment between gearbox and engine, gearbox not lubricated, excessive backlash between gears, worn out gears, gearbox bearings damaged or worn out pitted, gear teeth broken or worn out. Bearings. When a component slides over or rotates around another part, the surfaces that contact each other are called bearing surfaces. A bearing is a device placed between two bearing surfaces to reduce friction and wear. Sliding bearings are used at following conditions: low rotating speed, very large bearing surfaces, low use applications. Sliding bearings composed of a relatively soft bronze alloy, many are trade with steel with bearing surface bonded. Rolling bearings or anti-friction bearings such as roller bearing, ball bearings, etc. are used in high-speed applications, high load with relatively small bearing surfaces and high use. In gearbox, gear rotating on C-fixed shaft can have more than one bearing surface. It is supported and held in place by the shaft in a radial direction with the help of the bearings. Bushes. Bushes are cylindrically shaped and held in place by press fit. Since bushes are typically made of a soft metal, they act like a bear and support many of the rotating parts. It takes the radial load. Thrust washers. It's fitted with roller bearings. Thrust bearings or washers are used to limit the end play and also reduce the friction between two rotating parts. Roller bearings are used in combination with flat thrust washers to control end play of a shaft or the gap between a gear and its drum. Static. A seal used between two parts that doesn't move in relationship to each other. such as the pan and oil pump to case gaskets.
That's all for today. We hope you were able to understand all the topics covered during the session today. Looking forward to seeing you while we cover other interesting topics. Till then, happy learning. Thank you.